Welcome to episode 2 of Landon's Guide to High School Math. This is the Pre-Algebra course, and we are going to go over our next unit in this course, which is patterns. So last episode we did factors and multiples. If you want to check that out, that is the last video. Go check that out. And now we're going to do patterns. So let's get right into it. So let's go ahead and start off with patterns with numbers. So let's go ahead and talk about this. So the following pattern starts with 4 and uses the rule add 6 to the previous term. Which of the following statements is true? So what do we know? We start with the number 4, as we can see right here, and then we add 6 to each previous term. So we have 4, 10, 16, 22, 28. So what do we know about this? We know that if we add 6 to 4, we get 10. And then we get 16, and then 22, and then 28. So now we have to look at the choices and look at which is true. Choice A. Every other number in the pattern is odd. Well, that's not true, is it? All of these numbers are even. Remember, odd numbers have to end with a 1, 3, 5, 7, or 9. So this is odd. Whereas even numbers end with 0, 2, 4, 6, 8, and yeah. So none of these are odd. So it's not A. Choice B. Every number in the pattern is greater than the previous number. Hey, how about that? We got 10, which is bigger than 4, and then we have 16, which is bigger than 10, 22 is bigger than 16, and 28 is bigger than 22. So I think this is correct. So let's take a look at our last choice. Choice C. The pattern includes only multiples of 4. Well, that's not true because we have numbers like 10 and 22, which are not even factors. So C is not correct either. Choice B is our best answer because we can see that each number here is bigger. So B. So here's the step-by-step situation. So yeah, so we have evens. So there's no odds. And yes, so if you got that right, good job. If you didn't, there is a video. There's only one this time. It's a little less than last episode, but otherwise, happy studying. Okay, problem 2. Kira and Sam were born on the same day, but not in the same year. Their ages are shown on the table below. How old will Sam be when Kira is 36? So let's see if we can find a pattern here between these. So 9, 12, 16, 24, 30. Okay, let's see what we got here. So 9 and 12. So what do we need to get 12? We need 3. Would 9 plus 3 equal 12? Yeah, it would. So this first number, I think we're having a pattern. It's plus 3 for this first number. So plus 3. And now what about the next one? 12 and 16. What do we need to get 16 from 12? 4, good. 12 plus 4 is 16. And now what about 24? 8. Good. And now finally 30? 6. So the pattern is 3, 4, 8, 6. And now what about Sam's age? It starts at 12. And then what do we get if we add what to 15? 3. So I have 3 there. And now what about this next one? To 19. 4, good. And now what about 27? 8. And the last one? 6. And you can always pause if you want to answer on your own. That's why I'm getting these pauses. And hey, what do we know? We got the exact same pattern from Kira and Sam. So what we can do here is we can actually just count up because we know the patterns will be the same. So we want to know when Kira is 36. So we have 30. Let's count up to 36. 31, 32, 33, 34, 35, 36. So we counted 1, 2, 3, 4, 5, 6 times. So there's that, and now let's do the exact same thing for Sam, which will be our answer. So 33, 34, 35, 36, 37, 38. So let's see here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I think we need one more. 39. So 39 is our answer. So let's look at the choices, and it looks like B says that. All the other choices do not have the choice 39. So let's put that in. Yeah. Now let me go over a quicker way that we can approach this. So we know that age is always going to be like the same. Like if you are younger than someone, you can never be older than someone. So what we can do here and understand is we can take Kira's highest age and look at these numbers and understand that 3 is bigger than all of them. So if Kira is always going to be 3 less, 36, that's going to mean that Sam minus 3 is 36, because Sam will always be 3 more than Kira. So we need to subtract 3 in this equation to accommodate Kira. So that's another way you can approach that, which I'm pretty sure that's what it does. But this is an in-depth explanation, so if you got that right, great job. If you didn't, here are the videos. Otherwise, happy studying. Okay, question 3. The first day of Sam's vacation was on a Monday. What was the day of the week on Sam's 36th day of vacation? So, first off, how many days are in a week? 7. So if we know it started on Monday, then we have Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So let's take a look at this so we can start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Do you see a pattern here? If we do the entire week, we get 7. And then if we do it again, we get 14. It looks like every single time we loop around the week, it'll do 7. So what we can do here is we can multiply by 7 the amount of times until we get above or slightly under 36. So let's do it. 7 plus 7 is 14, plus 4 is, not 4, 7. 21, plus 7 is 28, plus 7 is 35, plus 7 is 42. But is 42 bigger than 36? Yeah, it is. So we should stop at 35. So 35 will be our Kira number. So if we loop around 7 days, then we'll know that if we have 7 and 7, we will end back on Monday on the 35th day. Now, to get 36, we have to add one more. So that means, what does this mean about Monday? So if you got somewhere like, it'll be 1 day after Monday, because look at this. We have plus 1, and if we take a look at our little chart here, so let me just write this out again. So if we add 1 from Monday, we move up 1. So what day will this be? T, which is Tuesday. So Tuesday is our final answer. What was the day of the week? Oh, wait a minute. Oh, that's my mistake. When we loop in Monday, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 8 the first time. So the first day is Monday. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 8, 15, 23, 31, and then 31. We'll stop right there. We need to find a number that will add up to 36. It is 5. So 5. So we need to do 5 days after Monday. 1, 2, 3, 4, 5. So Saturday will be our best answer here. So Saturday, what? Every 7 days. It'll be faster to count by weeks. It'll take one more day. What? Day of the week. Did I forget a day? 1, 2, 3, 4, 5, 6, 7. 7 on Sunday. 7 on... Oh, I understand. Okay. So, okay, that's my fault. I'm so sorry, guys. I didn't mean to. I'm so sorry. So, what I did wrong was I mistakenly thought it was Monday. So, I'm extremely sorry, guys. I'm really sorry about that. But it's okay. We all learn, and it's all part of the process. So, anyways, so we take our days. We have 1, 2, 3, 4, 5, 6, 7. So 7 is Sunday. So 35 is Sunday, and then we add one more, which is 36, which is Monday. So Monday is actually our answer. So very good. If you want to, here are the videos. Otherwise, happy studying. And again, I'm so sorry. Okay, so let's see if we can make up with that with this next problem. Which rule describes the pattern shown? 51, 54, 67, 80, 93, 106. So let's see what we're getting at here. So we either have to add or multiply. So first off, if we multiply by 8 by 41, what will that give us? Well, it's going to give us a really huge number. And same with 6 as well. If we do 41 times 6, what would that give us? Somewhere like this. But anyways, yeah, we know we're not multiplying here. Let's cross out C and D. Now let's see if we can find a pattern. If we can only distinguish the pattern between this first one, we'll have our answer. So 41 plus, will it be 13 or 15 to get 54? It'll be 13. Because we have 1 and 13 is 4, and then 4 and 1 equal 5. So our pattern here is adding 13. And if we look at the other numbers, they also add to 13. So you can check that if you want, but we only have to do 1 to validate our answer. So by completing this... Okay, we'll do that. If you want to videos otherwise... So yeah, we'll do that. Just for extra practice. Okay, so we want to videos. Otherwise, happy studying. Great job. Okay, bonus question. Vincent van Gogh is making one-color versions of all his paintings. He uses the colors in the following order and then starts over from the beginning: red, blue, pink, green, and purple. What color is painting 31? So we can take a look. So let's put R for red, B for blue, P for pink, G for green, and PU for purple. Okay, so let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, wait a minute. There's a pattern here. We're landing on purple every 5 times. We get 5, 10, 15. What do we know of? So these are multiples of 5. If you watched my first episode, then you would know that. But if you wanted a refresher, there you go. So yes, they are multiples. So we can take 5 and then we can multiply it. So we can do long division here, which I didn't distinguish earlier, and we can see how many times will 5 go into 31. Well, if we do long division, we can't subtract 3, so that's 0. And then we have 3. And then 31 minus how many times will 5 go into? 30, because if we take 5 and then we add it until we get above 31 or a little below, it's 30. So how many times is... So what's 30 divided by 5? What is this? 6, good. So we have 6 here, and then Now, we don't care about the actual answer to this problem. All we need is the remainder, and our remainder is 1. So now, what's the next color from purple? It's red, so we're reverting back to the beginning after purple. So the color of painting 31 is red. Good job. So, yes, we could use division, long division, which we did. And then, yep, we used our pattern. So if you got that right, great job. If you did not, okay, videos. Otherwise, happy studying. Okay, we did that first one, so this is all our progress that we have for today. So let's do our next one, patterns with shapes. Okay, let's see what we got here. Whoops, that was a mistake. Whoops, here we go. Okay, in the following pattern, every group of rectangles has one more rectangle than the group before it, and there is a rhombus before every group. Which of the following statements are true? So, it looks like here we're having a pattern where we add one more to each one. So it's like after the first one, there's 1, there's 2, there's 3, etc. So, meaning, what would that mean for the next 4 shapes? They would all be rectangles, because if we're adding one more, then we can distinguish that. So, 11, 12, 13... I'm really bad at writing numbers. Okay, but yes. So, we can take a look at this. Choice A. The next group will have 4 rectangles. Hey, how about that? We just distinguished that. We just wrote 4 rectangles right here. And then we have a diamond here. So, I think this is right. Let's remark that. Every rhombus is an odd number shape. Well, that's not true, because we have these 2 numbers, which are 6 and 10. And remember, all odd numbers must have a 1, 3, 5, 7, and 9. Some of them are odd, but not all of them, since it says every. Choice C. Shape 15 is a rectangle. Well, we have 11, 12, 13, 14, 15, and that's going to be a rhombus, not a rectangle. C isn't right either. Choice A is our best answer because it distinguishes what we just went over a few moments ago. So let's put that. And yay, we got it. Okay, so let's see which are rhombuses. So there's the explanation. It's not going to give me the video. But anyways, I guess I'll just do another variation, I guess. So we'll put... So here's the explanation right here. And happy studying if you got that right. Okay. Look at the following shapes. What does the pattern show? So let's see if we can find a repetition here. So we have triangle, rectangle, square, triangle, rectangle, square, triangle. So what am I getting here? Well, it looks like we have triangles, rectangle. It looks like it repeats. What could this be? Well, if we split it up, it looks like we'll do it twice. What if these could be something? Could it be triangle, rectangle? Let's look at our choices here. What is this shape right here? It's a rectangle. Does choice B say that the rectangle is the second option? No, it says it's a square. But the square is the third option, so it's not B. And now, what is this shape? And the fourth one. It's a triangle. Does choice C demonstrate that? No, they say that it is a square, but it's a triangle. So the best option is triangle, rectangle, square, triangle, which is clearly demonstrated in this pattern. So A is our best answer. You can look at this. Maybe there's no video for this one. Just the explanation, I guess. So, anyways, if you got that right, good job. Happy studying. If not, there's the explanation right here. Okay, next one. What will the 7th shape in the pattern be? First, let's see what the pattern is. So we have circle plus triangle. Circle plus triangle. Hey, how about that? It looks like it repeats right here. So that's our pattern. Circle plus or triangle. So if we repeat that many times, it looks like we got 6 of them. So since there's 6 of these already, in other words, it's saying what's the next shape going to be. So will it be, what one will it be? A circle, yeah, because we're repeating our pattern back with the first circle. So that means choice A is our answer. So here's the explanation if you didn't get that right. But otherwise, happy studying. Okay, last problem. Ooh, here's a long one. Max is a professional table organizer. For today's event, he brought square tables. A single square table can seat 4 people, 1 at each side. As in the first picture below, each circle is a person. If Max joins 2 tables along a side, as in the second picture below, he can sit 6 people. How many people can Max seat with even more tables? Extend the pattern and fill in the chart below. So let's see here. It looks like we're combining tables, because as you can see, with one table you can fit a bunch of people, but you can't do that here because you can't put humans into tables, right? That would be weird. So let's see what we have here. We have this diagram. So we know that 2 circles have 1, 2, 3, 4, 5, 6. We know that. But now, what if we add another table? So there will be, let's count, 1, 2, 3, 4, 5, 6, 7, 8. So what am I getting here? It looks like we have 6. If we add another square, it looks like we jump up by 2, because we have 8 here. What if we were to add another square? So we would have 4 squares now. So let's count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, I think that's our pattern. We're getting that we're adding plus 2 for each one. So that's our pattern. So we can put that in. So that's our pattern. We start with 4 and then we just add 2. So that's the pattern. Yes, we add 2. So let's apply it. So we have 3 tables. We just said that there are 8 people. 4, we add 2, which is 10, and then 5, we add 2 again. What will this be? 12. Good job applying the rule of adding 2 to each one. Let's check our answer. And then, yep, we add 2 each time. So here's the step-by-step solution. It's a pretty big one. So I'll go ahead and just scroll. Otherwise, happy studying. All right, very good. So that's the end of patterns with shapes. Let's move on to our next one.
Alan.
Okay, shush. Okay, so constructing. Okay, create expressions with parentheses. Which problem could be solved with the expression 32 divided by 3 plus 1? So we are going to use an acronym with this one, since we are given this. Now, I know our answers are going to be words, but I'm just going to teach you something that's a little off topic. We're going to be using what's called PEMDAS, or if you're from the UK, I heard you use, like, Bob does. But please focus up a little bit, because there is a huge confusion that's even being applied today. So, when we use PEMDAS, this is what we use for order of operations. So, let's go ahead and break it down. P stands for parentheses, so this would be this. Do parentheses first. Exponents are basically like squared, cubed, whatever. Multiplication is self-explanatory. You probably do multiplication in this lesson and right now. Division is also pretty self-explanatory because it is in this problem. Addition is self-explanatory and subtraction is self-explanatory. And you must go in this order. However, that's only the case with these. Parentheses and exponents. Multiplication and division and addition and subtraction are interchangeable. Because let's remember that that maybe division, for example, because when we take a problem, let's just say 10 divided by 5, that's equal to 2, right? We know that. And what about 5 times 2? It's 10. But notice how these problems, they are, let me actually just write it as this, just so we can get a better visual. Now, notice how you kind of flip the numbers to the other sides, but you change the symbol. Because multiplication and division are, multiplication is backwards division, and division is backwards multiplication. So these two, so just for future reference, these two are interchangeable. Same thing with these. Like, we know that 1 plus 1 is 2, but we also know that 2 minus 1 is 1. We did the exact same thing. We flipped the numbers, and we got our answer. So A and S are also interchangeable. So we know that now. So what do we do with this? When we're doing a problem, so let's just say we had like maybe 3 plus 1 times 2 divided by 4. So what we do first is PEMDAS. We do the P. So let me actually add that. So we do P. So we do 4. And this is still in parentheses, because 3 plus 1 is 4. And then squared. So we have 4 squared, which is 16. And now we have times 2 over 4. So now we do our left to right rule. Left to right. So we do 16 times 2 first, which is equal to 32. And then we divide by 4, which is equal to 8. So this entire thing is 8, and that's because we used order of operations. So that's PEMDAS, and we will be using that a lot in pre-algebra. So get it locked in your head, and I will go ahead and put it up here just for your reference when we're doing this problem. Okay, now let's get to the main problem. Which problem could be solved with the expression 32 divided by parentheses 3 plus 1 parentheses? So let's take a look at this. Allie builds furniture. She built 32 chairs. She sold 3 chairs and broke 1. How many chairs does she have left? So I don't think this would really represent it, because if we built 32 and then sold 3 and then broke 1, she would lose a total of 4 chairs. But that's not what we're trying to solve here. We're trying to solve this equation, not this. So I don't think A is right. Choice B. Betty has 32 students she tutors. She got 3 additional students. She then advertised and got 1 more student. How many students does she have now? Hey, how about that? That does follow my claim. We're taking a look at, she got 3 additional students, and then she advertised and got 1 extra student. She got a total of 4. So yeah, that matches my thing. So yeah, B is probably going to be correct. Now I'm going to check number C. Choice C. Greg has 32 toys. He decides to split the toys evenly between him and his 3 brothers. How many toys will each boy get? Well, this isn't really it either, because we're including him, so it would be 32 divided by 4. So, oh wait. Oh, shoot. This is this. I mistaken that wrong. So it's actually C is correct, because we're split division. So I think, so yeah, C is the correct answer. So take a look at this. And yeah, so we have 32 minus 3 minus 1, 32 plus 3 plus 1, and then divide. So yeah. So if you got that right, great job. If you didn't, video. Otherwise, happy studying. Okay, let's go on. Terry plays baseball for 5 hours in the morning and 4 hours in the afternoon. He does it for a total of 30 days. At the end of the 30 days, he has a tournament and plays baseball for 15 more hours. What numerical expression shows the total number of hours Terry played baseball? So let's break it down. We have 5 hours in the morning, 5 hours in the afternoon, 4 hours in the afternoon. And he does this for 40 days. So how much hours does he play? How much hours does he play baseball a day? Well, it mentions 5 hours in the morning and 4 in the afternoon. So it's 9 hours of baseball per day. That's a lot. More than I sleep. And he does this for a total of 30 days. So if he does this every day for 30 days, meaning that he's going to do 9 every 30 days, what could we also write this as? 9 times 30. At the end of the 30 days, he has a tournament and plays baseball for 15 more hours. So we're adding 15. So just to simplify here, I think this equation will be 5 plus 4 times 30. And then he will do 15 more. So I think that's our equation. So give this a star, and then we'll find an equation close to that with the choices. Choice A, 30 times 5 plus 4 plus 15. So, no, this isn't our equation. This is assuming that he only plays baseball in the morning, and then he does the 15 more hours and does 4 in the afternoon. So it's not A. Choice B, 30 times 5 plus 4 plus 15. Hey, yeah, that's correct. Because parentheses, they can also mean multiplication. Now, for PEMDAS, parentheses, it only applies if there is actually an equation. So this 30 right here, this 30 actually doesn't require, well, no, it does. It does require parentheses. But, like, this equation and this are the same. Because it doesn't matter if you put parentheses or not. You can, but you don't have to. So, yeah, this is correct. So, I'm going to mark B right. Let's check C. Choice C, 5 times 4 plus 30 plus 30 plus 15. So, no, this has nothing really to do. This is mistaking multiplying the hours in the morning and the hours in the afternoon. So, yeah, this one is completely wrong. Choice B is our best answer here. So, yeah, we got that. Then plus 15. So, if you got that right, great job. If you didn't, videos. Otherwise, happy studying. Okay, let's keep going. Which problem can be solved with the expression 5 times 2 plus 4 divided by 6? So let's look at our choices here. Hayden made 2 bracelets before school and 4 after school each day for 5 days. Then he split the bracelets into 6 equal groups. How many bracelets did Hayden have in each group? Hey, yeah, that's absolutely correct. Because, we have 2 before school and 4 after school, which is represented here, and then he did each day for 5 days. 5 days. So, and then he split it into 6 equal groups. So, yeah, this is exactly what we're trying to find here. So, I'm going to mark A. Let's check the other choices. Choice B. Kai the dog ate 2 bones on Monday, 4 bones on Tuesday, and 6 on Wednesday. On Thursday, she ate 5 times more bones than the other days combined. How many bones does Kai eat on Thursday? So, this wouldn't be our claim. We want 4, 2, and 6. So, it would be more like this equation. So, that doesn't match this. So, I don't think it's B. Choice C. Shady is building a new back deck. He puts 2 nails and 4 screws in each board. He does this to 5 boards. How many total screws and nails did he use? So, we are correct with the 2 plus 4, and he's correct with the 5 boards, but he never included the divided by 6. He has to include the divided by 6. So, he should have done, and then he sliced maybe into 6 pieces. Then that would be correct, but he didn't include the divided by 6. So, well, I won't assume a he. So, whatever. They need to, include that. So, it's not C either. A is our best answer here, because it includes all our elements with this expression. So, we're going to guess A. So, here's this really long explanation. Here is the video. Otherwise, happy studying. Okay, last problem. Steve has been saving his money in different places around the house. The table below shows how much money he has saved. Steve's parents were so impressed with his savings that they doubled his money. Which numerical expression shows the amount of money Steve has after his parents doubled the money? So, let's see here. They doubled his money. So, looks like we already have these values, which is 10 plus 5 plus 15. It's interchangeable, don't matter. So, this is all his money. So, like, we have all this. I want to put it in parentheses, because if we do, like, times 2 here, then that would mean we are adding 10 times 15, which is 25, but then we're multiplying this. And that's not what we want. We want to do it in a parentheses, which basically is telling, so like, if we put this into a calculator, it's saying, hey, we want you to add this, but then we want you to multiply this. That's not what we want here. So if we, by adding parentheses, we're telling the calculator, like, hey, we want you to solve this and then multiply it by 2. So we want parentheses. So choice B doesn't have parentheses at all. This is exactly what I just demonstrated is not the answer. And now they double his money. So what does this mean? We're multiplying by 2. Good. So this is our equation right here. Let's go ahead and find the equation that is equivalent to our answer. Choice A. 10 plus 15 plus 5 times 2. So this is just saying what I said is not the answer, but in a different way. It's adding parentheses here and adding parentheses here. Which, first of all, is not necessary because it'll still be the same answer either way. And second of all, this is wrong. Choice C, 10 plus 15 plus 5 times 2. Hey, there we go. Now that's a good answer because now we have it in parentheses and we're going to double our money. So C is the correct answer. So we're going to mark C. So we have this. So if you got that right, great job. If you didn't, here's the videos. Otherwise, happy studying, and remember PEMDAS. Okay, so... Ooh. Oh, I skipped one? Oh, shoot. Alright, well, I guess at least we did that, so... Let's evaluate expressions with parentheses. Okay. Where can we put parentheses in 21 plus 21 divided by 7 to make it equivalent to 6? So, we want an answer equivalent to 6. So, it looks like we only have 2 options here. So, what we're going to do is we're going to use what we learned from PEMDAS and evaluate. So, let's take a look at choice A. Choice A, 21 plus parentheses, 21 divided by 7. So, let's see here. We can use PEMDAS, which is 21 divided by 7. That is 3. Good. And then we have 21 plus 3 is 24. Is that equivalent to 6? Nope. This is not right. This is equivalent to 24, not 6. So, A is wrong. Now, we know B is right, but let's just check it to make sure it is equivalent to 6. And Khan Academy didn't make a mistake. Okay, anyways, 21 plus 21 divided by 7. So, we can do our PEMDAS by adding 21 and 21 together to get 42, and then divided by 7. Will this be equal to 6? Yes, indeed. So, they didn't make a mistake. So, the answer is B. Here's the solution. If you got that right, great job. If you didn't, here are the videos. Otherwise, happy studying. Okay, next problem. John tried to evaluate the expression 5 divided by parentheses 15 minus 2 times 3. His work is below. In which step did John first make a mistake? So first, let's go ahead and break it down. What is the correct way to do this? So let's do 45 divided by 15 minus 2 times 3. So we're using PEMDAS here. So are we going to do 15 minus 2 first or do 2 times 3 first? Yeah, we're going to do 15 minus 6 first. And I know I said PEMDAS first, so whatever is in the PEMDAS, we also do. So if there's PEMDAS in PEMDAS, then we do the PEMDAS first. And if there's PEMDAS in PEMDAS in PEMDAS, we do the first PEMDAS first. Wait, not PEMDAS. If there's parentheses in parentheses, we do the inner parentheses first, because the outer parentheses are always last. So there's only one parentheses, then we don't have to include other parentheses. Now, that may seem confusing at first, but as it gets more ingrained into your brain, it'll be very easy and accomplishable. So let's keep going. So 15 minus 6, what is that? 9, good. And since that is all our parentheses, we can just say 9 without the parentheses. So now 45 divided by 9 is 5. So 5 is our answer. So let's go ahead and take a look. So, okay, step 1, 45 divided by 15 minus 6. Hey, wait a minute, that's right here. And it looks like that is correct. So step 1 is not a mistake. So let's mark that wrong. Step 2, 3 minus 6. Ooh, I see what he did here. He tried dividing 45 divided by 15 without the minus 6, which is wrong. He's supposed to divide the entire parentheses. So step 2 is a mistake. So that means B is our answer. And we don't have to keep going because it's where he first made a mistake. Even though step 3 is correct, though. But if it would have been wrong because of step 2's mistake. So here's the explanation. If you're good job, otherwise videos, and happy studying. And if you're new here, I do try to feature the videos because they are really helpful. Credits to Khan Academy. But if you want to ask me for help in the comments, that is absolutely okay. I do encourage that. Okay, evaluate. Okay, so now we're actually just dealing with a PEMDAS. So let's take a look at this equation here. So we have this. So what's our first step here when it comes to PEMDAS? Parentheses. So 3 plus 7 is 10. So 10 here. And then we have 6 plus 4 times 10. And this doesn't have to be a 10, but I'm just doing it for the tutorial. Okay, so do we do 6 plus 4 first or 4 times 10? 4 times 10, because now we do multiplication. So that will equal 40. And now we add 6 to get 46. So 46 is our answer. So 46, good. And then, yep, we use PEMDAS. And Khan Academy doesn't tell you that. So you just learned something new today, I hope. But yes, anyways, if you got that right, great job. You're doing amazing. Otherwise, videos. And it's okay if you're struggling. We're all new. Math is hard for many people. But that's why I'm here. I'm here to give you all the best math support I can get. So anyways, happy studying. Okay, next problem. Where can I put parentheses in 4 times 3 plus 1 plus 2 to make it equivalent to 12? So we got another one of these. Let's go ahead and see which one of these choices will be correct for us. So we have A, 2 times 3 plus 1 plus 2. So let's evaluate this. So 2 times 3 plus 1 plus 2. So are we going to multiply 2 and 3, or are we going to do the parentheses first? Parentheses. So what's 3 plus 1 plus 2? 6. Good. So we have 6. So 2 times 6. So what does that equal to? 12. So that means that, and hey, how about that? It says 12, 12. So A is our answer. Now let's go ahead and check. Let's go ahead and check B to see if there is maybe another answer that's 12. So choice B, 2 times 3 plus 1 plus 2. So when it comes to parentheses here, we have separate parentheses. So it doesn't matter which one we're going to do first. So for the purpose of the tutorial, I'll do this one first. So let's see it here. 2 times 3, that's equal to 6. And then plus 1 plus 2 is 3. So that would be equal to 9. Now, is 9 equal to 12? No, so B is not our answer. So A is our answer here. And here's the solution. If you got that right, amazing job. If you didn't, here's the videos. Otherwise, happy studying. Okay, let's keep going. Patrick tried to evaluate the expression 4 times 8 minus 3 times 2. His work is below. In which step did Patrick first make a mistake? So let's see here. So first let's get the correct equation of this. So we have 7 times 8 minus 3 times 2. So, what do we do first? Are we going to multiply 7 and 8? Do 8 minus 3? Or 3 times 2? 3 times 2. So, that means that we'll have 6 here, and then 8 here. And then 7 times, what are we going to do next? Right. We have to finish off the parentheses and get the answer of 2. So then we have 7 times 2, which is equal to what? 14. So this is the correct solution. Let's find where he first made a mistake. Okay, step 1. 7 times 8 minus 3 times 2, okay. 7 times 5 minus 2, aha! Here's what he did. He subtracted 8 and 3 first to get 5. But that was wrong. He was supposed to do 3 and 2 first because we use the acronym PEMDAS. Multiplication is before addition. So, with this in mind, step 1 is our answer. And we don't have to continue because it's where he first made a mistake. Even though the rest of it is correct. So, boom. So here's the explanation. If you got that right, great job. If you didn't, videos otherwise. Happy studying. Alright, that was a whisper. Okay, here we go. Evaluate. So, we have more parentheses. So, whatever we solve first does not matter. So, let's go ahead and solve. So, 27 divided by 3 is 9. Good. And now, what about 5 and 9? 14. So, we have 9 and 14. Oh. Shoot. Hello? Okay. No. So, 9. No. So, we have 9 and 14. Oh, go ahead. Good. Okay, anyways, so we have... So we have 9 and 14. So, what? Yeah.
Are you doing more of that tutoring?
Yeah, I am. We have 9.
Do you think you should maybe be focusing on your school?
9 and 14, which is 1 and 4. I want to do extracurriculars.
Okay, well you have all summer to do extracurriculars. You have like 5 weeks of school left to really focus on getting straight A's. I think that should be your priority.
Oh my. Oh. So we have 120. Okay, so that's our answer. Yeah. I'll make it a priority. So,
Hey Landon,
yeah.
you have your call at 5 o'clock.
Yeah. Okay.
Do you have a reminder set?
Okay, welcome back. We just had a little bit of technical difficulties there. So let's go ahead and just move on to where we left off. Where can we put parentheses in 32 divided by 4 to make it equivalent to 2? So let's see here. We got 2 options here. We have 32 divided by 4 plus 3 times 4. So let's see here. Let's go ahead and evaluate each one. So remember, PEMDAS. So we have 32 divided by 4 plus 3 times 4. So we have 32 divided by 4, which is 8. And then 3 times 4, which is 12. So we do 8 plus 12, and we get... Dude, that lost me. Okay, 20. So that means A is not right. Okay, choice B. 32 divided by parentheses 4 plus 3 times 4. So we do 32 divided by 4 plus 3 times 4. So what are we going to do here first? Right, we have to do parentheses. What do we do first in the parentheses? Yep, we have to multiply first. So we do 32 over parentheses 4 plus 12. Very good. And now what do we do if we add 4 and 12? We get 16. And notice how I didn't include the parentheses because we completed it. And this is equal to 2. So that means that B is correct. So let's put that in here. And yep, it was correct. And that was our last problem too. So yep, here's that. If you got that right, good job. If you didn't, here are the videos. And happy studying. Okay, next lesson. And then we'll take the quiz. Translate expressions with parentheses. Which expression represents 60 divided by the product of 4 and 3? So, let's see here. So, remember that the product means multiplication. There are some transitives. Addition is the sum. So, addition is the sum. Subtraction is the, let's see, we have the sum. I can't think of it, but this is the product. And division is the quotient. What is the... Okay, so, yeah, I don't know that, but... Well, I probably do know it, but I just don't know it on the top of my head. But anyways, so we want the product of 4 and 3, which means that if we want 4 and 3, we need 4 and 3 to be together. So we can immediately eliminate A because it says that it's 60 divided by 4. And it says 60 divided by, which means that 60 will be first. So that means that our only answer here must be B. So we put that in. Here's the explanation. And if you got that right, good job. Videos, otherwise happy studying, and you can always ask me for help as well. Which expression is 4 times as large as the expression 34 minus 5? So, yeah, this might be a little wordy, but that's okay. Let's break it down. So, 4 times as large. That means we'll be multiplying by 4. So, okay, it looks like all of these have 4 times. We want the expression 34 minus 15, which means that these must be together. The only answer where I see that is answer... If you got B, good, because notice how they're in parentheses. So, 4 times as large. And remember, what could be another answer? So, we can try and describe it in our own words. Another answer to this problem could be interchangeable. So, maybe 4 times 34 minus 15. And also, this time, it doesn't even have to be in parentheses, because we are going this way. However, this one must be in parentheses, because then, if it wasn't in parentheses, then it would be 34 minus 15 times 4. It would be minus 60, 34 minus 60, and that would be a negative number. That negative number would be negative 26, which is absolutely not what we're trying to find. Now, you'll go over more in negative numbers as you continue progressing through the course, but other than that, our answers are B and optionally D. But we don't have D. Let's just pick B and we can look at the explanation. So yeah, so look at this. So we have this. Now Khan Academy did put parentheses, but again, it's not required as we will go over multiplication first. And then we have this. See, it's commutative, so that's why that you can do either or. So these are the same. You know, heck, even this is the same. Like, that's the same. That's the same. That's the same. That's the same. It's crazy, right? Everything that's connected with anything using a parenthesis, or even just leaving it as is, will work. So, like, this will work. I mean, I'm pretty sure you get the point. But if you're still confused, you can always ask me for help, and I will assist you as soon as I possibly can. So if you got that right, great job. If you didn't, here's the videos. Otherwise, happy studying. Okay, next question, not the last one. Which expression represents 175 more than the quotient of 72 divided by 9? So let's see, we got the quotient of 72 divided by 9, so I know that 72 and 9 must be connected, yeah, in some way possible. So it has to be parentheses or even just together. So let's see here. Ooh. these answers, A and B, do not represent 72 and 9 being connected. This is the only one I'm seeing. And also, we have 175 more, which means that we must have a plus 75, which is above. So C is our only answer here because it represents both of these elements. 175 more and 72 divided by 9. So these must be our final answers. So let's go ahead and put that. Amazing. So here's that. And yep, addition is cumulative as well. The only ones that are not cumulative are subtraction and division. There are times, though, where it is cumulative, but only in a few ways. One, when there's an exponent. So, for example, 2 minus 1, and so these are not the same. But as soon as I add something like this, now they are the same. Because later in the course, you'll learn more about exponents. And exponents are part of PEMDAS, but we're not really using them quite yet. But it's basically repeated multiplication. So, for example, if we have 3 squared, then that would be equivalent to 3 times 3, which is equal to 9. What would 4 squared be, given that we have this information? Well, we have 4 and 4 because we multiply 2 times, because the exponent tells how many times we need to multiply 4. So then we get 16 from this. So if you don't understand it right now, that's perfectly fine. We're not even there yet. So you have plenty of time to learn that. You have plenty of time to learn anything. Even if you're struggling with this, it's okay. Everyone has their own levels. So if you got that, great job. If you didn't, here's the video. Otherwise, happy studying. Okay, last problem for this one. Which expression is 3 times as large as the expression 610 minus 97? So I know that this must be together. So it looks like all of those just demonstrate that. We're also given that we have times. What does times mean? Multiplication, good. So 3 doesn't demonstrate that. It demonstrates addition. And now, we want 3 times as large as these expression. Ooh, that reminds me, one of the previous expressions that I said you didn't need parentheses, you do need parentheses. I was saying 3 times as large as this number and this number, which is my mistake. So, A is still incorrect here. We want the expression 610 minus 97, which means we have to solve 610 minus 97, and we covered earlier, like, these expressions. So, what would be the answer here? If you got C, you are absolutely correct. So, again, like, if you put this into the calculator, you're saying, hey, calculator, I want an answer that is 3 times bigger than 610 and then subtracted by 97. And that would not be what we want. But then C here, it says, okay, calculator, I want you to evaluate 610 minus 97 and then multiply it by 3, which is exactly what we want to get based on this given expression. So C is our only answer here. So let's mark it, and boom, we got it right. So now we know the expression y before an actor multiplication is cumulative. So here is the video. If you got that right, great job, and happy studying. Okay, that is the last thing. Now we're going to go ahead and take this quiz right here. So we're going to do this quiz, and then we're going to move on to the second half of this unit. So I'm going to go ahead and give you guys some time to pause, and then I will give you the answer. So, question 1. Which problem could be solved with the expression 6 minus 4 plus 1 times 2? The answer is C. If you got that, great job. In the following pattern, every second shape is a quadrilateral, and every third shape is filled in. Which of the following statements are true? If you got B and C, then you are correct. Great job. Stephen tried to evaluate the expression 3 plus 6 times 2 divided by 4. His work is below. In which step did Stephen first make a mistake? The answer is B. If you got that, great job. And which rule describes the pattern shown? The answer is D. If you got that, great job. Which of the following shows 144 divided by the difference of the expression 70 minus 34? If you got B, good job. If you got all these right, good job. You are good to go. If you got 4, pretty good. Maybe review a little bit. If you got 3, you might want to review a little. And then 2 and if you got 2 or lower, then you might want to go back and review. Okay, shut up. You might want to review some previous rules that we covered in this video. Okay, rules that relate to variables. Which rule describes the relationship between the x minus and the y minus coordinates in the following table? So what we do here is now we look at our function and we look at what do we do to get these answers. So do we see a pattern here? 2 and 10, do we have any sort of maybe multiplication? Maybe we can multiply? Because all of these must have the same relationship. So if we multiply x by y to get y, that has to be the case for all these answers. So 2 times 5 is equal to 10. Good. So now, what about 4 times 5? That would be equal to 20. So we have 20 right here. But is that equal to 14 as given here? It's not. So A can't be our answer. Okay. B, multiply x by 2, then add 6 to the result to get y. So if we multiply by 2 and then get 6, which I can also write that as x. 2 plus 6 equals y. So if we plug in x right here, and plugging in basically just means that replacing the number with its value. So since x is 2 here and y is 10, we need to plug in chuck, which is just, it's just representing the numbers. So, is this correct? If you said yes, good job. 4 plus 6, because you multiply these, and then that gets you 10. Not 100, I wrote that wrong. But yeah, 4 plus 6 is indeed 10. Let's try that for the next one. 4, 2, plus 6, y is 14. Is this correct? If you said yes, good job. This is indeed correct. All we have to do, because we multiply this to get 8 and then 6. The only thing we have left to do to validate is 6 and 18. So we have 6, 2 plus 6 is equal to 18. Now, is this correct? Yep, this is indeed correct. Because you multiply this to get 12. And then plus 6 is equal to 18. So hey, how about that? That is correct. That does match my claim. So we can say that we can multiply x by 2 and then add 6. It wouldn't be subtracting. That's the opposite of what we want to do. Because if we multiply x by 4, so like maybe we do 2 times 4 and then we subtract 6, that would get us 8 minus 6, which is 2, which is not what we want. So it's not C either. B is our best choice. So we answer B. And then we take a look at these. 2 times 5 equals 10. 4 times 5 is not 14. So if you got that right, great job. If you didn't, here are the videos. Otherwise, happy studying. Okay, next problem. Which rule describes the relationship between the x and y coordinates in the following table? Okay, let's see what we got here. Do we have anything? Well, let's try out some of these rules. Choice A, add 2 to x to get y. So this is x plus 2 equals y. Because we get add 2 to x, so that's that, to get y. To get y equals. This can also be 2 plus x equals y. For the purpose of the tutorial, I will write it as that. So let's plug and chug. So 2 plus 2 is 4, is that correct? Yeah, it's right. Because 2 plus 2 is 4. I mean, it's addition. Okay. 3 plus 2 is 5. No, not 5. 6. Is this correct? No, this isn't correct. 3 plus 2 is 5, and I kind of just gave that away, but yeah. Okay, add 2 to x to get y. No, that is incorrect. So, we know A is not right. Choice B, multiply x by 2 to get y. So now, we are saying 2x equals y. And notice how I didn't do x times 2. Something that is going to be really useful to understand is that this is the same as this, and that is the same as that. So if you want to take a screenshot of this, I promise you it will be so important in pre-algebra, algebra 1, geometry, pretty much in every high school math class. You're going to need to know that this will be your principal variable that you'll use, 2x. It's just a shorter and more simple way of saying 2 times x is equal to this. So 2x is equal to y. And later on, this will even be on a graph. A graph that will look something like this. But we'll get to that later, probably in Algebra 1. So anyways, let's do it. Let's plug and chug with 2 is equal to 4. Because we're plugging in values over here. So what is our answer? So, yeah, this is right. 2 times 2 is indeed 4, and that's equal to 4. Okay, so what about 2 and 3 from over here? This is equal to 6. And is that equal to y? Yep, y is equal to 6 as stated. What about 2 and 4? So, what is this equal to? 8, and y they do state is 8. So, hey, how about that? It looks like B is correct here. It wouldn't be x by 3 and then subtract. So, what they are saying is that it should be this equation. So, if we plug in x over here, equals 4, we would get 6 minus 3 is 4, which is not correct. It's 3, and that's not equal to 4. B is our only answer here. So, it's B. If you got that right, good job. If you didn't, here's the videos. And happy studying. Which rule describes the relationship between the input and output pairs in the following table? So now we are given an input and an output here. So sorry about that, technical difficulties. Okay. Anyways, okay, which rule describes the relationship between the input and output pairs in the following table? We have an input of 2, and an input of 3, and an input of 4, with outputs of 1, 3, and 5. So, now what we're doing, input and output are just a fancy way of saying x and y. So, we don't even have to worry about it being x and y. So, what we basically have to do to get the answer is the same thing we did for doing the XY stuff. So, this can be multiply x, so we can just scribble that out, x by 1 to get the output. And then same thing, subtract 1 from the input, we'll put x to get the output, which is y. And then multiply x by 2. Then subtract 3 from the result to get y. So now, doesn't this just look so simpler by removing those? Oh, I forgot to remove that. So boom. Doesn't that look so much simpler to get our answers here? So let's try it out. Multiply x by 1 to get y. So let's see here. It's saying that x by 1. And what is anything times 1? It's just itself. So here it would just be x. They're basically saying that, hey, x is y. And while that's true for 3 and 3, it's not true for the other ones. 2 is not equal to 1, and 4 is not equal to 5. So these are incorrect, which means that A is wrong. Okay, choice B, subtract 1 from x to get y. So x minus 1 is equal to y. So is that the case? Well, although that is the case for 2 minus 1 is equal to 1, it is not true for 3 minus 1 equaling 3. 3 minus 1 is equals 2, and that's not equal to 3. So that means B is eliminated. So it's probably going to be C, but just to confirm, might want to check that to make sure that Khan Academy might have made a mistake. That they did not. So multiply x by 2, okay, so that's 2x, and then subtract 3 from the result to get out the output. So this is our equation here. So let's try it out. So we have 2 and x, which is 2, so 2 minus 3 equals 1. So let's see, is that correct? Well, 4 minus 3 is equal to 1. And that is correct, so that first one's right. Now, what about the next one? If we plug and chug the values, so we have an x and a y that are both equal to 3. So we have 3, yep, we're just plugging it in. Because see how the x and the x and the y and the y? I hope this is all making sense. 2 times 3 minus 3 is equal to 3. Now, is that true? We get 6 if we multiply, and then minus 3, which is equal to 3. So 3 is equal to 3, which means that this one's right. We only have one more. Let's see if we can validate this. To plug in our last value, 4 minus 5 is equal to, no, not 5. 3 is equal to 5. Now, is that correct? If we take 8 minus 3, and it will be equal to 5. So, yeah, all of these will work if we use this equation right here. So, C is our best answer. So, let's put it in. Let's look at this solution, and yep. If you got that right, good job. If you didn't, videos. Otherwise, happy studying. Okay, next up. Which rule describes the relationship between the input and output pairs in the following table? Let's see what we got here. Do we have a pattern? Well, let's see here. Let's look at the choices. Choice A, add 6 to the input to get the output. So again, now, I'm not going to scribble it this time, but the input is x, okay? So I'll only do it for this one. The input is x, and the output is y. So add 6 to x to get y. So x plus 6 is equal to y. So is that correct? If we plug and chug here, for the first one, it's correct. So we'll put that in. Now, what about for the next one? If we plug in 5 for this one, plus 6 is equal to 15. Well, although it's correct for the first pair, 3 and 9, it will not be correct for the second pair. So, A's out. It's not going to be add 6. Choice B, multiply x by 3 to get the output. So, So this is 3x equals y, because remember, it's commutative. Okay, you know what? It's interchangeable. So that means it can be x times 3, 3 times x, 3x, whatever. For the purpose of the tutorial, I'll use 3x. So let's see if we have a pattern here. If we plug in chug 3 here, what will we get? We get y. And is that equal to y, the output? Yeah. Hey, look at that thing. It looks kind of like a bow tie. A little fun fact. Okay, yes, anyways. So, yeah, it is equal to y. Okay, next up. 3 and 5. Good. So then we have 15 here. Is this correct? Yeah, 3 times 5 is 15, and then this is also 15. So this is also correct. Last one. Let's see if it's right. 3 and 7. Will this be equal? It'll be equal to 21. Very good. It means all of these are correct. So that means B is our answer. Now, what if we tried multiplying 3 by 2 and then adding 5? That wouldn't work, because 3 times 2 is equal to 6. And then we add 5, we would get 11. So, that means that C is out as well. It means B is our best answer here. So, B is our answer. So, if you got that right, good job. Here's the explanation. And here are... Let me just get back in here. I guess. Okay. If you got that right, good job. If you didn't, videos. Otherwise, happy studying. Okay, we got that. Alright, we only have 4 more, and then we are done with this unit. Okay, tables from rules that relate to variables. Let's see what we got here. A table is made using the following 2 patterns. Pattern X, starting number 5, multiplied by 3. Pattern Y, starting number 20, rule multiply by 1/2. So, with this, we don't have to know the starting number. The starting number is unnecessary because it's already given on the table. So, the only 2 things you need are this and this. So, for X, we're multiplying by 3. So, we're plugging it in. So, we have 5 and 3. So, what's 5 times 3? 15. Very good. And now, what if we multiply 15 by 3? What will we get? 45. So that's the end with that rule. Now we have to multiply by a fraction. Now, when we're multiplying by fractions, how will this work? If we multiply a fraction, we multiply the numerators and the denominators straight. So 20 times 1 is 20, and then 1 times 2 is 2. And 20 divided by 2 is 10. Another way you can think about this is understand that multiplying by a half is just multiplying by 2. Because when you're multiplying fractions, you're taking the reciprocal. And the reciprocal of 1 over something, so like, for example, 1 over x, the reciprocal will be x over 1, or just x. The same thing applies here when x, well, not like xx. I'm talking like this thing. So, the reciprocal will be 2, which means that 20 can be multiplied by 2. So that means 20 times 2. So, it'll really just... Oh, you multiply? Oh, no. Not multiply. If we're multiplying by a half, we divide by 2. So it's the other way around. If we were dividing by a half, we would be multiplying by 2. So 20 over 2 is 10. Yes, we just said that. Okay, so, and then now using the same rule, what do we do here? We divide by 2. Good. And now, what's our answer? 5. Very good. So this should be our table. So let's look at our solution. And yes, we could have multiplied, but we can divide by reciprocals as well. Each one will work perfectly fine. Okay, so if you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying.
Oh, hi.
Hi.
So you're going to come outside with us?
Yeah. Yeah, ignore the background sounds. So let's just keep studying. Here, actually, it's going to be so exciting. We're going to study in nature. Okay. A rule for creating the pattern is given below. The rule is to multiply x by 0.5 to get y. Which ordered pair xy works for the rule? So, we are given that x has to be worked for 0.5. And then we have another rule, which is getting y. So from the last section, we learned, I'm sorry. Okay, so we can put here 0.5x equals y. So this basically, this can also be represented as 2y is equal to x. And this will probably also be easier to comprehend since we don't have to deal with any annoying, pesky decimals. So, we have x is equal to, hello. Okay, is equal to 2y. So then we plug in y for our given value. So we have our plug-in value. So we have to find the value that will be equivalent to what we're trying to solve. So what we are trying to
Did you pick the Koopa?
So we take a look at our choices. We have A. So we have 1 and 5. So we can plug and chug. We have 1 is equal to 2 times 5. So will this be equal to each other? Nope. 1 equals 10, which is wrong. So it's not going to be A. Choice B, 5, 10. So we have 5 is equal to 2 times 10. Now, this is a common mistake based on many people, but this is also going to be incorrect. 5 is equal to 20. Good job on accurately multiplying 2 and 10. So when we have this function here, then we will have this wrong. So when we go ahead and take a look at this thing. So we have 10 and 5 here, so now we take our final one. So B is wrong. So let's check out number C, and just to confirm if it's right. So we have 10 is equal to 2 times 5. So we have 10 is equal to 2 times 5. So is 2 times 5 equal to what we're trying to solve here?
I need it.
Yeah, it's 10. So that means that C must be our best answer here. So we'll go ahead and get our solution here. And yes, we take an ordered pair and we plug and chug it into our following values. We could have used 0.5x equals y, but for the purpose of this tutorial and tutoring session, I feel like representing the principal variable of x will be better for getting y's. So if you got that right, good job. If you didn't, then here are the videos that Khan Academy provides you. And happy studying! Okay, a rule for creating a pattern is given below. The rule begins with a number called the input and creates a number called the output. Multiply the input by 2 and add 4 to the result, get the output. Blah, blah, blah. The input is equal to x, and the output is equal to y. So we need to find a value that will result in 2x equal to y. So let's see here. We have input, which is equal to x. So we have 2 and 3, and then we have the output, which is so 10. So we have 2 times 3, it's 6. So 6 is equal to 10. That's false though. So A is wrong. So that means now we can try the other one. 2 times 1 is equal to 8. Now is that correct? Nope, that's wrong. 2 is not equal to 8. So now we take our final value. So this is wrong. So we have 2 is equal to 2, which is 4. So is 2 times 4, is 2 times 2 equal to 4? Yeah, 4 is equal to 4. So that means that C has to be our best answer. Now, if you need help, go ahead and ask me in the... Oh, add 4. Oh, I didn't add 4. Okay, so that's my fault. So let's just retry the choices we have and just see if we can confirm anything. So we have 3 and 2 plus 4. So this will be our new value. 2x plus 4 is equal to y. So what is 3 times 2 plus 4? Yeah, it's equal to 10. Good job. So, and that matches our output. So actually, A is going to be our best answer. So we can look at our equation and look at our thing. And yeah, it looks really good. So that was my mistake. I did not see this add 4. So it's good to read the question carefully. Okay, so if you got that right, good job. If you didn't, videos. Otherwise, happy studying. Okay, next problem. Complete the table for the given rule. 3 is it's my video. Y is 3 less than x. So here we have y. 3 less than x basically means that we're subtracting 3 to get x. So what we do here is we have to
Go get my cell phone.
so we have to
I have to go get my cell phone.
So we have to, what do we do here? We get y is equal to x plus 3. Now, how did I do this? I added 3 on both sides, which will be more talked in depth in Algebra 1 later. But what it will be is you will add on both sides to cancel out variables. Because what is 5 minus 3 plus 3? Well, first of all, how would you normally do this? I mean, well, it could be different, but maybe you would add 5 and 3 first to get 2, and then you would add 3 to get 5. But can we understand that -3 and 3,
Ruby.
we do remember that addition is interchangeable, right? So that means 3 minus 3 and -3 plus 3 are the same thing. So that means that, and x minus x is equal to 0, because we have 2x combining, so it just means nothingness. Like, maybe my one fist has the same power as my other fist. If we collided, it would be absolutely nothing, because that is the existence of math. So the best way to do this is to take these two and get 0. So 5 is equal to 5. So we have y equals x plus 3 here. So we would plug in each value and we would fill in the blanks for y. So what we're basically doing here is adding all these numbers and adding them by 3. So we have 10. So we have 10 for x. So what is 10 plus 3?
Go back inside, Landon.
What?
You're not visiting with us. You're just annoying us. Go inside.
So it's 13. 13. Okay. I'm so sorry, guys. I don't mean to be this way. It's new. It's a new thing. I'm so sorry for the background noise. I would try, but Okay, so here, you know what? We can still enjoy the nature. So let me get out here and okay. This should be okay. So, anyways, 5 minus 3 plus 3. So, here we have, here, 3 and -3. Since it's the same 3, then they are interchangeable. So, that means that they are both equal to 0. So, what this also means is that we can just put 5 here and then cancel out these. So, that's the same way I got this and this. So, y equals x plus 3. So 10 plus 3 is equal to 13. So that means I plugged in x for this one. So y must be equal to 13. And now, what would we do for the exact same one? What would be 8 plus 3? 11. So we have, so far we have 13, 11, and one more value that we're about to find out. What is 6 plus 3? 9, good. And notice how some of these might be easy for some of you guys. That's good. So y is 3 less than. Oh, wait, y is 3 less. Oh, I'm so sorry. Okay, this is terrible. Okay, so if y is less, then remember from the previous segment that we have to accommodate y. So y plus 3 is equal to x, and y is equal to x minus 3. So now we're just subtracting 3. So we get 10 minus 3, 8 minus 3, and 6 minus 3. Where are these all equal to? 7, 4, and 3. No, wait, no. 7, 5, and 3. So, good job. You got 7, 5, and 3. So there we go. We got this. And if you got that right, good job. If you didn't, here are the videos. Otherwise, happy studying. Okay, 2 rules for creating a pattern are given below. 1, divide x by 4 to get y. And 2, subtract 18 from x to get y. So we have y by 4 to get y. So x over 4 is y. So to make this a little more simple, let's do x is equal to 4y. Subtract 18 from x to get y, meaning that we get this value right here. So what is the ordered pair if we're doing both sides? Well, we can actually plug in values for values. If we know that x is equal to 4y, does that mean we can also plug that in for this variable right here? Well, let's see if we can. 4y minus 18 is equal to y. So what do we do here now? Well, what we do is we try to cancel out. So we have to subtract a certain number of y from each one. So maybe we need to move this to the other side. How do we do that? Well, here we have a positive. We want to move that to the other side, meaning that we want to get 0. Because remember, there could be like imaginary zeros after the y, which are not necessary unless absolutely necessary. So since we have imaginary zeros, they are going to be our best friend. So if we subtract 4y, this will turn out to be 0 minus 18. And if we subtract 4y from y, in other words, what is 1 minus 4? Or what's 1 minus 4? A good way I like to put this is doing 4 minus 1, and that we know is equal to 3. However, it's the exact same thing. When you're doing interchanges with subtraction, you get that same answer except you put a negative sign. So you do negative 3. So you do 0 minus 18 is equal to negative 3. And in fact, you don't even need the 0 anymore. Negative 18 is equal to negative 3y. I forgot to put that there. So now, if we divide by negative 3 on both sides, what would we get now if we divide that? 6. So that means 6 would equal to x. And now that we have x, so we know that 6, oh no, not x, y. And since there's only one choice that has y, then we know that a is our answer. But let's just keep solving just for the purpose of this lesson. If we plug it in for this value here, we have 4 and y. So 4 times 6 is equal to 24. So that's equal to x. And remember, x goes first, as given right here. So it should be, what should be our final pair? 24, 6. So that should be our final answer, 24, 6. So here's our step-by-step solution. Okay, so if you got that right, good job. If you didn't, here are the videos. Otherwise, happy studying. Woo! Man, that took a lot of room, didn't it? Okay, 2 rules for creating a pattern are given below. Each rule begins with a number called the input and creates a number called the output. Rule 1, subtract 8 from the input to get the output. Divide the input by 3 to get the output. Which input and output table works for both rules? Well, if we subtract 8 from the input, which will represent as x, then we'll get a certain value. Now, even with one rule, we can eliminate choices here. So let's try it out. We have input, and then now we want to subtract 8 from the input. So we're subtracting 8, and what does that give us? 10. So now we have 10, and the output of that will be 6. So 6 is the output, and 10 is not equal to 6. We can immediately eliminate answer choice A, even with only one rule, which means now we're down to 2 choices, B and C. Now we have to divide the input by 3 to get the output. So let's see what we got here. Choice B. We do 12 over 3, and what does that give us? 4. Good job. So, what is that our output? Yeah, that is our answer. So that means that B must be our final answer here, because if we tried it with C, then this would be dividing by 2, because we have 16 and 8. That's divided by 2. Although the first rule works, the second doesn't. And B is the only answer here that follows all the rules. So here's step-by-step solution. If you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying. Okay, last problem for this one. A table is made using the following 2 patterns. Pattern X, starting number 12, rule add by 8. So again, starting number 60, rule divide by 2. So again, we don't need these. The only numbers we need are this and this. So for X, we are adding by 8. So X plus 8. And notice how it's not going to be 2020. Whatever will be our output will continue on from there, which I think I explained in the first problem. So what is 12, because that's X right here, plus 8? 20, good. So now we continue on from there. So 20 is our quote-unquote new X. We continue on and move it down here, plus 8. What is that equal to? 28. So that means that this must be 20 and 28. Now, y, we have to divide by 2. So let's go ahead and do this. So we have divide by 2. So y over 2. So we have 60 here. So 60 divided by 2 is 30. And then 30 divided by 2 is, since we moved that over here, it's 15. So it should be 30, 15. So it should be 20, 28, 30, 15. Perfect. Okay, so there's that. And since I didn't read that, and we can get more practice, if you got that right, good job. If you didn't, videos. Otherwise, happy studying. So let's do one more bonus problem just for you guys. A rule for creating a pattern is given below. The rule begins with a number called the input and creates a number called the output. Multiply the input by 6 to get the output. So we have the input, which is X. I really do not like that they call it the input, but that is some math terminology that you may be required to use when you get into class. So 6x is equal to y. So, if we plug in 0 for x, well, first of all, anything times 0 is equal to 0. We know that. Now, is that equal to our output? No, our output is 6. A is not our answer. Okay, option B. If we plug in 2, what will be our answer? 12. And is that equal to our output? Yeah, 12 and 12. Very, very good. It means B is our answer. We don't have to, but we can check. Okay, so 6 and 1. So we put in 1. What is that equal to? Well, anything times 1 is just itself, right? In this case, it's 6, since we have 6, 6. Is that equal to our output? No, the output is 7. It's mistakenly adding 1. So B is our only option here. So this is wrong and this is right. So B is correct. So good. We get all this. So if you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying. Great job, everyone. So now we only have 3 more to go, and then we're good. All right, graphs of rules that relate to vehicles. Let's see what we got here. Ooh, here we go. Let me introduce you guys to graphs. So a graph is basically a 2D graph is what we use to find points on a center plane. Now, this may all seem very confusing at first, but please do not worry. I will help you guys all throughout the way. I'll help you through Pre-Algebra 1, Algebra 1, Algebra 2, and beyond. I will help you guys along the way. So if you've never seen it before, this is a graph. So this is a graph of rules. Now it has things called axes, which is spelled like this. And now, the horizontal axis, which is this line right here, is called x, and this is y. So this line right here, that's known as the x-axis. And the other line, which is over here, is known as the y-axis. So just call them by the variable and you're good. Now we use points. Now the middle is what's going to be known as the origin. Now we use a standard notation xy, which we have been using, and this will be very, very important. You're going to be doing a lot of graphing in Algebra 1, so I want to really get you prepared for that. So let's go ahead and try this first problem out, and I will help you along the way. The points on the following graph show the relationship between x and y. First, complete the table of x and y coordinates. So you have given x is 1, that's 2, that's 3. So now, which rule describes the relationship between x and y? So we have two parts here. So let's take a look at our graph. Now, when we're on a line of the x or y axis, that will be 0. So if you are like over here and line on the x-axis, then your y value is going to be 0. Now, it may seem confusing, but remember, because if you are not, because the more right you go, the more positive you get. The more left you go, the more negative. In this case, we're only talking positive. So we're looking at positive integers. So since x is more of the right towards the y-axis, it's going to be positive. So that means x will not be 0. So this means that y is equal to 0. And this means that x will be equal to 0. So just remember, if it's on the x-axis, y is 0. If it's on the y-axis, x is 0. Okay, first complete the table of x and y coordinates. So let's see here. What did we just learn? We just learned that the x-axis means that y is 0. So given this knowledge, what is the y here? 0, good. So now that means that's 0. And now when it's not on any axis, now it's actually on a point. So we want to line this up with what point it could be. So we go up, and what could this be lined up to? So what is right below this point? 2, which is our x that's given. Now what about our y? It may not be given to us since we have 2 points, but we can understand that the middle of the 2 and 4 is 3, since we're counting up by 1. So that means that that point must be 2, 3. Now, how would we put this point into standard xy notation? So this notation. It would be put as 2, 3. That would be a point on the graph. You can try this on Desmos, you can try it, you can ask like your teacher, but yeah, it works. Okay, next up, 3. So we are given that we have a 3 for the x. Now, where is 3x? It's right here. So that means that this point going straight down, it will be 3. Now, if it goes to the left or to the right, depending if it's positive or negative. If it's positive, you go to the left to find out where your thing is. Or if you absolutely want to, you can just draw a whole line. Whichever number it intersects, and as you can see, I'm very bad at drawing lines. Whatever number it will intersect, that's going to be your number. So since it touched the number 6, good. That means that, what will be our y? 6. So that means that that's that. Now, next problem. Next, which rule describes the relationship between the x and y in the graph? So it says multiply x by 0, then add 3 to the product to get y. Multiply x by 3, then subtract 3. So let's see what we got here. So now we can take what we learned from the last section, and then we can interpret that. So let's do it. So multiply x by 0, so that's 0x, and when we have anything times 0, it's just 0, right? And 0 is nothing, so we don't even have to worry about that first part. You're literally just adding 3 to the product. So it's x plus 3 equals y. Let's try it out. So So 1 plus 3 is equal to 0. Is that right? No, that's wrong. Let me explain to you how B is our right answer. Multiply x by 3 and then subtract 3. So let's see here. So this is 3x minus 3 equals y. So we have 3 times 1 minus 3 is 0. So is that right? Yeah, it's right, because we have 3 times 1, and anything times 1 is itself, and then 3 times 3 is 0. So 0 is 0. So, yeah, this is correct. Now, so the rest of them, just multiply the x values by 3, and then subtract 3. And then you'll get your answers. So the answer here is B. Let's look at our solution, and wow, it's a lot. Yeah, as you can see, we did our up method. So yeah, so all of that. And yes, only 2 matches it. So, if you got that right, good job. If you didn't, some videos, and it may be very important for those just starting off graphs. But anyways, happy studying. Okay, here we go. The following rule describes the relationship between x and y. To find y, multiply x by 2 and then add 4. So to find y, it's going to be multiply x plus 2 and then add 4. Now, this is what's called, here, I'm just going to introduce this. This is called slope-intercept. Now, slope-intercept is going to sound like a very, very weird word. But trust me, I'll break it down and you'll get it right immediately. So, slope-intercept is what we use as y equals mx plus b. Now, x and y are pretty self-explanatory. We've already discussed them. The new variables we're talking about are m and b. So, m is equal to the slope. Okay, slope. So, if m is the slope, that means that how much is going up per second. So, for example, if the slope is 1, then that means that the x and y's are going to go up. It's kind of like this. Now, that's kind of a more like straight slope. If the slope was like 2x, like here, then it would go up more than usual. So, the y will always move forward by 1. But the x is what's changed. The y will always stay the same. It will always be 1y. So maybe the slope is like 1/2 x. Maybe it's a fraction. Well, now it looks like that y is going more, only because x is going less. So, and then b is what's known as the y-intercept. And that's literally a fancy way of saying it's when the point crosses the y-axis. So, maybe right here, when in choice A, when does this cross the y-axis? Right here in the 4. So the y-intercept will always have a number of 0 for the x, and then y depending on where it intersected. So where did it intersect? So you can draw a line of like where maybe the line maybe intersected. And 4. So here in A, the y-intercept is 0, 4. That's how you put it in a XY notation. So that's slope-intercept. So I'll leave this up for a little bit. Okay, good. So let's go ahead and do our problem now. So anyways, our problem is y equals mx plus b. So multiply by 2 and then add 4. So what would be our slope here? It would be 2 because that's for m. And then what about b? 4. So plus 4. So, okay, so now we plug in x. So we have y is equal to 2 times 0 plus 4. So what is anything times 0? 0. And now we have plus 4. So what's 0 plus 4? 4, yeah. So now notice actually here, 0, 4, correct? We just figured out that that's our y-intercept in A. So what does this mean? Well, if you say A is our answer, ding, 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 you got it. Because here, we also have the x-intercept. Now, you'll do more y-intercept, but x-intercept, it's literally the same thing, except now you're intersecting the x-axis. So, this would be wrong. So, we already know that A is going to be our answer, which means we can also kind of use this graph to find out what our other answers could be. But we can also just simply plug it in. Yeah, you have 2 choices. You can graph it, or you can just plug it in. Now, my recommendation is just plugging it in, but whatever your preference is, don't matter. So what's 2 times 1? 2, good. And then what's plus 4? 6. So y equals 6. So that means that this one is 6. And now for 2. So we have 2 times 2 plus 4. So y is equal to 4 plus 4 is equal to 8. So that means that this is 8. So now we have 0, 4, 1, 6, and 2, 8. So let's check it. Nice. It's amazing. So here's the explanation. If you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying. Okay, we're doing great. Third problem. Ooh, now we're plotting the pairs. Okay. The following rule describes the relationship between x and y. Rule: multiply x by 0, then add 7 to the result. Okay, so we have multiplying x by 0. So, first of all, what is anything times x? 0, yeah, so we don't even have to put anything. And then add 7. Ooh, here's something I want to talk about. When the slope is 0, you're going to learn this a little later, kind of in like the middle, kind of like near the end of Algebra 1. You hear terms called Hoy and Vux. What Hoy and Vux are basically like there's no slope at all. There's no slope or there's either no slope or the slope does not exist. So Hoy stands for horizontal zero slope y line. So that means that the slope is 0, and it's going to go in sort of this direction right here. A Vux stands for vertical undefined x-line. So it's going to go up like that. So since we know that y is equal to 7, that will be the case for any value. It does not matter if x is equal to 4.3.4, whatever thingamajig it might be. Heck, it could even be a random number that doesn't even exist. Y will still be 7. So, what does this mean? Yeah, like, y will be 7. 7, 7, 7. Because y is literally 7. Like we can star this. And now, this is known as a Hoy because we have a y value. So, it doesn't even matter where you put this. We are going to have a value. So, like, 3x, yeah, we can put that. So, yeah, we can put that, but really, it just really does not matter where you put it. It's a Hoy. It's H-O-Y. So, yeah, if you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying. Okay, we have only one more problem with this one. The points on the following graph show the relationship between x and y. First, complete the table of x and y coordinates. Next, which rule describes the relationship between x and y in the graph. Okay, so we have to find 1. So if we're going down, that's 1, right? Now if we go to the left, because it's positive, what will it be? Y is 3. Good job. Very good. Now if we go to maybe 2, what will y be? 6. Good job. Okay, so now if we go to 3, which is right here, and I'm really bad at that. Okay, where are we going to be? 9. Good. Okay, so now we have some pattern. Multiply x by 4 and then subtract 1. So we have x by 4, which is 4x, and we subtract 1 to get y. So we have y equals 4x plus minus 1. That is ahoy. Now, if we subtract 1, your b is your y-intercept, correct? So I'm also going to explain slope here, just because this could be the last graphing section. Slope is defined as... Now, this is the formula for slope. It's y2 minus y1 over x2 minus x1. So this basically means that you have to have at least 4 values over here. So say you take like y2, which is 6, minus 3, and then you take 2 minus 1. Now trust me when I say this, it may be confusing. And yeah, it took me a while to learn this formula. But slope is 3 using this value. So that means that this is also correct, which means that these are kind of equivalent depending on what you do. So you just do that. So with this in mind, we can find slope easily, and then we just take the y-intercept. So if we have a y-intercept, we have rise over run. So we rise, and then we run. So slope, it's equal to that. So let me just recap. Let me recap. So that's our equation. So our slope is our rise over run. So our rise over run. So now what we do with our rise over run is when we rise up, we have to count. So 1, 2, 3. So we have a rise of 3 because that's just how much we're going up or going down. If we're going up, it's positive. If we're going down, it's negative. And when we're running, same thing. If we're going to the right, it's positive. If we're going to the left, it's negative. It's a good thing we're only focusing on positives. But eventually, when it does do something like that, then you will have to. And if the line is going up like that, it'll be positive. If it was going down, we're going negative. Yada yada. It's a lot of stuff. We will cover it in future episodes, so don't worry if you don't know right now. I will cover it in future episodes. So, looks like it only goes 1, so it's over 1. So that means that slope, we can also define it from there. But anyways, there's that. Let's just go ahead and answer the second problem now that I've explained what slope is. So, multiply x by 4 and then subtract 1. So, let's see here. So we have... Ooh, okay. Ow, kind of hurt my hand. Okay, so multiply x by 4 and then subtract 1. So we have 3 is equal to 4, 1, minus 1, and then 4 minus 1. Is this correct? It would be 3 equals 3. So this one is right. So let's check the next one. So let's see. I'm just going to put this... just because it will always be there, we'll just have to plug in y and x. So, plug in y, plug in x. So, we have 4 times 2 is 8, and then minus 1 is 7. But is that equal to 6? It's not. So, it's not going to be a. It's going to be b. If we multiply each value, 1 times 3 is 3, 2 times 3 is 3, and 3 times 3 is equal to 9, which means that it's going to be b. So, we'll check that. And then we have our step-by-step solution, which we demonstrated all of that. So if you got that right, good job. If you didn't, here's the videos. Otherwise, happy studying. Okay, great job. We only have 2 more, and then that's all we are learning for today. And then we'll take our unit test, and then we'll resume tomorrow. So here we go. The table uses the following 2 patterns. Pattern X, starting number 39. Okay, so again, we do not need to know the starting number. The only things we need are this and this. So we have x. We have the rule to subtract 9. So we have 39 minus 9, which is 30. And then we subtract that by 9, and that will be 21. Good. So that means that we have 30, and we have 21. Okay, so now we have 33 here. So then we take 33, our answer, and then we subtract that with our formula. So we have 33, and then we subtract it by 11. So we have 33 minus 11, which is 22. And then we subtract that by 11, which is 11. So if you guys understand, I hope I'm not going too fast. Because if you don't understand, please ask me. I will not hesitate to help. So our answer should be 30, 21, 22, and 11. So we get that. We get a step-by-step solution. So we take our answer. So we got that. If you got that right, good job. If you didn't, here's the video. Otherwise, happy studying. Okay, here we go. The table uses the following 2 patterns. Pattern X, starting number 21. Rule subtract 3. Okay, so again, we don't need the starting numbers. We only need this and this. So rule subtract 3. So let's do it rapid fire this time. What is 21 minus 3? 18, good. And now what about 63 minus 9? 54, I kind of went opposite. Now let's do this. 18 minus 3. 15, and then we have 54 minus 9. 45. So it should be, our answer should be 18, 50. So it should be this, and this. So do you guys understand? You're just subtracting 9, and then you just keep doing that. Just keep doing that forever. So you do that, and that, and that. So let's check. Boom. We got a pattern. And then we just keep doing that infinitely. Now, what if we kept going and we just kept subtracting toward infinity? Well, eventually it would be negative infinity. Because when our pattern goes into an infinite way. Because, again, math has no limits. You will always find a math problem in your life. It has no limits. It'll always come to you whatsoever. It is so important. So if you got that wrong, here's the video. If you got that right, good job. And happy studying. Okay, third problem. The table uses the following two patterns. Pattern X, okay, so again, we do not need the starting number. We need this and this. So let's do it. 4 plus 7, what is that? 11, good. And now what about plus 7 again? 18, good. So we have 11 and 18. So we put 11 and 18. So now we have 15 and we subtract it by 2. So then we do 13, and then we subtract it by 2, and what we get? 11. So we have 13 and 11. So very, very good. You guys are doing amazing. I love you guys. So let's check it. And good. Let's do this swing. We got that. Yep, we got our pattern. So we got that right. Good job. Here's the video. Otherwise, happy studying. The table uses the following two patterns. Pattern X, starting number 12. Rule, add 12. Okay, so we don't care about these. Looks like the rule is adding 12 twice. So now we are just going to add 12 to both of these numbers. So let's just actually do it double time. So let's see what we got here. So we have this, and then, so what do we get? 12 plus 12 is 24, good. And then we add 12, which is 36. So then we do 16, same rule. So we got plus 12 is 28, plus 12 is 40. So we have, so these should be our answers. So it should be 24, 36, 28, and 40. Very, very good, everyone. So, yep, you get those. So if you got that right, good job. Here's the videos. Otherwise, happy studying. Great work, everyone. We only have one more exercise until we have... So this is the last thing we are learning today, and then you have covered the entire Unit 2 of Pre-Algebra. Here we go. The table uses the following two patterns. Pattern X, starting number 32, rule subtract 7. Pattern Y, starting number 34, rule subtract 7. So, we don't need starting number. It's given right here. And it's the same pattern. So, the terms in pattern Y are blank than the terms in pattern X. If this is the same rule, then can't we just take what is more of 34 and 32? I mean, I guess we can. Well, no, we can, period. Because if we subtract, we get 2. And then we can do the same thing for the others. 27 minus 25, it's 2. 20 minus 18, it's 2. You see how we're getting 2 for every single answer? It means that the terms are always 2 more than the terms in pattern X. What if this was the terms in pattern X are blank than the terms in pattern Y? What would that be? Well, that would be equivalent to less, not more. So this would be our answer. We can check our answer. Here we go. If you got that right, good job. If you didn't, here are the videos. There are plenty of them to show. There are 4 of them. So if you don't want to watch them, just go ahead and ask me. And happy studying. Okay, the table uses the following two patterns. Pattern X, starting rule number 1. We don't care about the starting number. We said that many times. Rule add 3, rule add 6. Okay, so plot the ordered pairs X, Y from the table on the following graph. So now we're actually going to apply our knowledge of applying rules. So it looks like they gave us some values already. So let's go ahead and plot them. We have 3 for X, so we have to find 3 for X, which is right here. So let's move our thing over here. And then we have to find our Y, which is right here. So, right here. So, which is right here. It's right over here. So we move this over here. This is 3, 6. What would be 6, 12? Well, if we mark 12 here and then go until we hit 6, we get this. So we have to move our second thing over here. And then we add 6 again. 12 plus 6 is 18. So 18 will be our number. So it will be 918. So these should be our pairs, and we also have 18. So we check, get our solution, and we just keep going up for our y's. And we see we are on a constant linear regression. So if we got that right, good job. If you didn't, here are the videos. Otherwise, happy studying. Okay, the table uses the following 2 patterns. Pattern X starting number 3, rule add 6. Pattern Y starting number 1, rule add 2. Okay, so the terms in pattern Y are blank times the terms in pattern X. So let's take a look at this. It says blank times the terms. So we have X and Y, so we have 3 over 1. And then we have 9 over 3. And then 15 over 5. Because if we take a look at Y, it looks like we have a Y, and it looks like we have 3, 9, and 15. So, do we think that Y is a lot less than it's intended to? We probably should eliminate the whole answer choices. It should either be 1/2 or 1/3. Now, what if we do 1/3? Is 9 times 1/3 equal to 3? Well, if we multiply fractions, like we get 9 over 1, because remember 9 and 9 1 are the same, and then we have 1/3. So we have 9 1, 9/3, 9 over 3, 9 divided by 3 is 3. So yeah, hey, how about that? That does match our intended claim. So yeah, that is our answer. And we do multiply. So we do try each pair. So, if you got that right, good job. If you didn't, here are the videos. Again, there are a lot of them. If you want help, just ask me in the comments. Otherwise, happy studying. Okay, last one. This is the last one we're doing for the day and with my help. So, please make the most of it. Okay, terms in pattern Y. Looks like Y is greater than X. So we are going to be using a whole number. It's either 2 or 5. So what if we use 2? Will that equal 10? Yeah, it will. So that means 10 is equal to 10. So that means that it is 2. So very, very good. Here's the solution. We do our 2 times x. I don't like how they do 2 times x. It just be y equals 2x. But again, it's correct. I won't blame them. So we've got that right. Good job. Up videos. And happy studying. So that is the last one. You guys are amazing. Now we are going to do the quiz, and then we are going to do the unit test. So if you get 8 or higher on the unit test, then you have demonstrated that, and you have followed along during this entire episode. So let's get into it. Go ahead and solve number 1. And remember to pause, okay? This should be your answer. If you got that, good job.
Bye, Landon.
Bye.
No! I got 20 to go.
Okay. Answer is C. If you got that, good job. Answer is A. Good job. The answer is 5 less. If you got that right, good job. It should be this thing, this, and this. So that means that should be your answers. So then we have, that means B is your answer. If you got that, good job. So if you got all those questions correct, then you did it. Okay, it is time to take the unit test. So remember, if you follow along and you get 8 or more on this unit test, then you have demonstrated your skills thoroughly throughout this video. So, good luck, and let's hope for the best. Unit test starts now. This is the answer. You got that, good job. This is the answer. By the way, if you didn't get, maybe I'm just bad at teaching, but again, I'm a high schooler, so. Remember to pause. Unless you want to just follow along, I guess. Okay, this is the answer. This is the answer. This is the answer. And fun fact, I'm actually doing this live with you guys, so I'm actually doing this depending on how fast I am. This is the answer. This is the answer. This is the answer. This is the answer. And this is the answer. If you got all those questions correct, well done. And look at that, we have just mastered Unit 2, which means we have demonstrated that we know how to do Unit 2 proficiently. So that is the end of this episode. If you enjoyed this episode, so yeah, they can see. Look at that. Okay, so that is the end of this episode. If you enjoyed this episode, please consider to give a like and subscribe. Our next episode, we will be going over ratios and rates. So, we will be tuned in tomorrow. But anyways, I hope you guys enjoyed this episode, and I will see you later. So, goodbye.